Okay, in terms of synthesis of alcohol, in our list comes synthesis of phenol. What we use is Dow's process. In case of Dow's process, we start with chlorobenzene, use sodium hydroxide at 623 K and 150 atmosphere. Now, whenever we are carrying out any reaction under pressure, we do it in autoclave. Autoclave is identical to pressure cooker, which I have used a lot during my research programs. All right. Okay. So what we end up with is NaO as represented in variety of colors gets attached to this. Na loves Cl, so NaCl formation is there, and along with NaCl, which is the byproduct, forms sodium phenoxide. Sodium phenoxide. This on acid hydrolysis gives phenol. Cl again reacts with Na to give sodium chloride salt. That's how we synthesize phenol using Dow's process. From cumene. This is what is cumene. Alright. Cumene on oxidation with air in presence of cobalt naphthenate. Now, structure of cobalt naphthenate is this. We know this is structure of naphthalene. This is carboxylate. So 2 second position is attached carboxylate, 2 second position is attached carboxylate. So 2 of this molecule with cobalt forms cobalt naphthenate. At 423 K gives phenol. Now see, when prior to getting to phenol, it forms cumene hydroperoxide. We know OO bond is peroxide bond. So hydrogen, if there would have been one hydrogen over here, we would have called it as hydrogen peroxide. But that hydrogen is replaced by cumene. So we call it as cumene hydroperoxide. Alright, now mechanism wise what we find is this OH group which is there is migrating to this place, and this bond is getting shifted to this O. As a result of that, we get C double bond O, and this bond is shifted to O. So basically this bond is shifted here, bond broken, O negative migrating to this point, this bond broken, forming C double bond O. So on forming C double bond O, this forms acetone. Alright, this forms acetone. Whereas this OH attaches over here and forms phenol. Alright, so that's how we synthesize phenol. Okay. Now let's again synthesize phenol from benzene sulfonic acid. Sulfonic structure, sulfonic acid structure. S double bond O, S double bond O, OH. And then here it is, instead of H, we have benzene attached to it. Alright, so benzene sulfonic acid. This on neutralization with, this is acid part, right? On neutralization with sodium hydroxide, so this and this on neutralization would form water, and sodium would get attached here. So minus water, and what we end up with is sodium benzene sulfonate. Sodium benzene sulfonate, Na plus O minus. Then what we do is we do fusion with 2 moles of sodium hydroxide for 1 mole of sodium benzene sulfonate. So what happens is we get Na2 SO thrice. So one N is adding over here, right? So it forms Na2 SO thrice, sodium sulfite, and there were 2 OHs, right? Sodium hydroxide, 2 OHs. Alright, so ONA, this goes out as sodium's Na2, so Na fixes over here, so it forms Na2SO thrice, Na fixes over here to form Na2SO thrice, what is left over here is NaOH. One NaOH is left behind because one Na has gone for forming this. One NaOH remains over here and another OH of another NaOH remains here. So of that, ONa attaches over here to form sodium phenoxide. Alright, and one H of this and OH of NaOH forms water. Alright, so when 1 mole of sodium benzene sulfonate is fused with 2 mole of sodium hydroxide, we end up with sodium phenoxide, and as a byproduct we get 1 mole of water and 1 mole of sodium sulfite. That on treatment with hydrochloric acid. Now this part is identical to Dow's process. With dilute hydrochloric acid, hydrolysis gives you phenol, obviously with sodium chloride as byproduct.